Practice 11.5, we're going to find the volume of some prisms. So a lot of people on a problem like this where we've got a rectangular prism, which is a box essentially, are just going to do the length times the width times the height, so 7 times 4 times 3, and that will work totally fine. I'm going to do it as the area of the base times the height, just because this will work for all prisms, not just rectangular prisms. So it'll work actually for cylinders as well, and if we had a triangle at the base or any type of polygon at the base. Okay, so the base is just going to be a figure that's repeated throughout the So I could have used this side as the base as well and thought of it on its side. The area of the base. So I got an uppercase B for the area of the base. Area of the base I'm going to get from 7 times 4, and then the height is going to be 3. So I just think kind of like if this is a stack of pancakes, the area of one pancake would be 28, and then I'd have 3 pancakes stacked up, because that's the height. That's the distance from one base to the opposite base, actually, from my bottom pancake to my top one. Okay, so I've got 28 times 3. That comes out to 84. Okay, and then my units are cubic inches. For volume, it's always third degree units. Okay, because we're working in 3 dimensions. Okay, so I can use the same formula here, area of the base times the height. So if this is my pancake, my stack of pancakes is slanted a little bit. So some people will use this as, I mean, I don't have the measure for that right now, but some people use that as the height of the stack of pancakes, but you actually want to use this. So think about your the distance from the top pancake straight down to the table, not to the bottom pancake, but straight down to the table they're sitting on. Okay, so for the area of the base, I'll do 9 times 8, and the height is going to be 12. So I've got 72 times 12. Comes out to 864. And I've got cubic centimeters there. Okay? And we can extend that, that formula right here. You just got to think, well, how would I get the base? The base here is going to be a circle. So you need to know the area formula for a circle, which is pi r squared. So the book has this different formula for the volume of a prism, but it's just the same thing. It's just, hey, that's how, whoa, it's just, let's see if I got any more. There, it's just the area of my base is going to be pi r squared, right? So the radius of that base is going to be 5. And then the height is the stack of pancakes again. The height there is 4. Okay, so let's see. I'm going to get 25 pi times 4, which would be 100 pi. So you could leave it like that. Or you could do a decimal approximation. It doesn't say here, so let's see. I'll put 100 pi in my calculator. 314.16. Makes sense, because 3.14 is pi, right? Oh, and I made a mistake here. I said square feet, but this should be cubic feet on both of these. Okay, same kind of deal here. I'm going to use 10 as the height. So area of the base times the height. Area of the base, I'll do pi r squared. And then the height will be 10. So I'm going to get 36 pi times 10. That would be 360 pi. And I've got yards. That comes out to 1,130.97. Okay. All right, next up, Now we've got the volumes on these next three problems, but we're supposed to find the variable. So this is supposed to be an S here. So I need to find S. So I would just think, well, what's my volume formula? I've got the area of the base times the height. So my volume here is 240. I'm just going to start plugging things into this. My base I would get by 5 times S. And then my height would be 8. So let's solve this for S. So 240 is going to equal 40S. Divide by 40. And I'm going to get 6. And it's going to be the same units as the other dimensions, so 6 meters. Okay, same property over here. Thinking area of the base times the height, and since this is a cylinder, pi r squared times the height. All right, let's start plugging pieces in. I've got 1244 for the volume. Radius is 6, and the height is going to be t. Okay, so cleaning this up a little bit. Okay, now I want to isolate t, so I'm going to divide both sides by 36 pi. That will isolate the t. So I could probably reduce that. Well, let me just reduce it. So reduced, this is going to be 311 over 9 pi. But that's kind of a weird way to say that, right? 311 over 9 pi. Oh, that's messy. Sorry, 311 over 9 pi. So I'd probably do a decimal approximation of that. So I'll just use my calculator for that. And when you're using a calculator, I think it's helpful. Sometimes people get the wrong answers on these because they're not using their calculators correctly. So in my calculator, I don't need to write this down this way, but I'm going to type it in like that. Okay, so I'm going to do it, and it doesn't matter if you close the parentheses, but what that's telling me is that the pi is in the denominator. Okay, so if you just type it in like this, so I got a different answer because my calculator did 311 divided by 9 and then multiplied the result by pi afterwards. It didn't know that the pi was in the denominator. Okay, so the 10.999 number is the correct one. So I'll round that to 11.00. Another way you can get around that is just find the denominator first. So you could also just calculate what 9 pi is and then do 311 divided by that 28.27 number. And then I got that 10.99 number there, right? Okay. All right, moving on. These next two problems, it says that we've got similar prisms. Okay. So that just means they're enlarged or shrunk from one another, right? But they've got the same dimensions, or their dimensions are in proportion, I should say. Okay. So the common mistake here, we're finding the volume of prism B. Some people are going to say, oh, 8 is to 6 as 800 is to this volume. This is incorrect, okay? So I'm going to write that up here. This is the wrong way to do this. This is wrong, okay? And the reason why is because we're using two sides to compare the two volumes. So the side ratio is going to be 8 to 6 or reduced to 4 to 3, or you can do a 3 to 4. But that's not the ratio of the volumes, okay? So if my side ratio, or you could call this a similarity ratio, that is going to be 8 to 6, and I'll reduce that to 4/3, okay? Then my volume ratio is different. The volume ratio, I need to cube this. So it's going to be the side ratio cubed. So I'm going to take 4 to the 3rd over 3 to the 3rd. 4 to the third is 64. 3 to the third is 27. So my volume ratio is 64 to 27. So 64 is to 27 as my large volume is to my small volume. My small volume I don't know yet, but now I can solve for it by cross multiplying. Divide by 64, and I've got 337.5. Okay, now this is the volume of the small one, so it should be that many cubic meters. Okay, and I didn't have a way to find that directly, that volume, with just that one given piece of info, but you can find it indirectly by finding the volume ratio and then setting up a proportion. Okay, same kind of deal here, so I'm looking for the volume of the larger figure here. So I can say, well, I want to find matching pieces, so I'm not going to use the 10. That's just a red herring there. It's a distractor. But 8 is to 24, and here's the wrong way to do this again. 8 is to 24, as 25 is to x. This is incorrect because I used the sides to compare the volumes. I want to do a little side problem. The side ratio is 8 to 24. Let's go ahead and reduce that to 1/3. Okay, and then from that I can find the volume ratio. I'm going to cube the side ratio. So if the side ratio is 1/3, volume ratio is going to be 1/27. Now I can set up my proportion. 1 is to 27. My volume should be in this proportion, as 25 is to x. Okay, and then I can cross multiply, so x is going to equal 25 times 27, which is 675. It's that many. Oh, and this head's squared here, but that should say cubed because those volumes are always cubed, so I'll fix that. Okay. And there we go. Okay, see you next time.